I'm Meg Evans, the Managing Editor of Spectroscopy, and I'm here today with Charles Wilkins, Distinguished Professor of Chemistry and Biochemistry at the University of Arkansas. Charles, thank you for joining us today.
I'm glad to be here.
You were the first person to combine gas chromatography, infrared spectroscopy, and mass spectrometry into a single analysis system. How did you get started on that project, and what results were you hoping for?
Well, at the time, there were several people that were having the same kind of ideas, and I had reasoned at the time that combining several different spectroscopic methods would give us a lot more information than any single one would, and maybe more reliable results. So that was a basis for starting that research.
And what kind of results did you get?
What we were trying to do at the time was to get much more reliable identification of compounds and complex mixtures. And in many cases, one spectroscopic technique would give partial results, another one would give different partial results, but the combination would give an idea of the total mixture components.
You were also a leader in the combination of liquid chromatography and nuclear magnetic resonance spectroscopy in ways that opened the current use of HPLC NMR for metabolomic studies. Can you tell us a little about your work on that front?
That's actually pursuing the same theme, that different types of spectroscopic methods would give increased results. Now, the reason for NMR, of course, as organic chemists know, it's very good if you have enough sample. A problem, in fact, in that research was that with small samples, it's much more difficult. And our idea was ultimately to link NMR with several different other types of spectroscopy. We didn't get to that point in that particular aspect of our research.
What were your biggest challenges in the HPLC NMR work?
One of the biggest challenges was that most common HPLC solvents have very strong absorbances in the NMR, and therefore obscure the signals from the thing you're interested in. And so one of the problems was how to suppress those signals while getting the signals of interest. Another problem was that sensitivity was always an issue with NMR, and we want to have very small samples corresponding to this width of chromatographic peaks, and therefore we had to devise ways to deal with that.
And what did you come up with to deal with it?
Well, what we did was we constructed very low volume NMR sample holders that were actually directly interfaced to the HPLC columns. In our case, I believe it was about 160 microliter samples. Today, people use even smaller samples, but at the time, that was more or less state-of-the-art.
What is your current research focused on?
We're currently mainly focused on doing high-mass molecules by mass spectrometry. And particularly in that last couple of years, we've focused on polymer analysis because that's very challenging.
Okay, Charles, thank you so much for talking to us today.
You're welcome. Pleased to do it.